visual paths converge to a vanishing point. It is where convergence ends and divergence begins. And that's not hyperbole. It's actually where divergence begins. And I'm going to show that. Now, we've all seen how I originally showed it, but I've now gone out and got all the evidence to show that what I said actually happens. So also, you personally yourself are the dividing line of perspective, because if you draw a line from your feet to the sky, this is where we know everything from your feet goes up or appears to go up, and to your eye line, and everything above your eye line appears to go down. So you personally yourself are a dividing line of perspective as well. Now, here we have a bunch of ships, and we're just establishing what happens when things go beyond the horizon. So when something moves away from the horizon, because this is how we have to describe it, okay? So when it's moving away from the horizon, it appears to drop and disappear from the bottom up. As it moves towards the horizon, it appears from the top down. So this will happen all the time, every time, no matter what you ever see. Eventually things will disappear. And as they come back towards you, they will appear from the top down. As they move away from you, they will disappear from the bottom up. Now, interesting little fact, most of these ones here, right, these ones here are all from 20 feet. And I couldn't find any other flat earthers that have done these sort of GIFs. So unfortunately I had to use Wolfie, and I put Matthias in there because I thought I wouldn't be too biased. So these ones here are all from 20 feet. This one here is from 2 feet. This bottom one here, I was at 2 feet, and this was about 22 miles away by the time it disappeared. And if you actually look, you can still see the entire ship is still actually there. It's just disappearing. So this thing didn't actually go below the horizon. It just went into the distance. And
just for sig fig, at 22 miles, the 8 inch per square mile fig is what, 215 something?
Yeah,
200 miles drop. 200 feet rather of drop.
Yeah, and that's
like
probably
more
about
than the height of the
140 foot tall ship, somewhere around there.
More than the height of the actual vehicle, yeah.
But we can see the entire thing still. You can still see right there, and then right there. The whole ship is still actually there. It's now just gotten so far away. This is where our angular resolution and Rayleigh's criterion have kicked in there, plus some atmospheric effects or hemispheric effects.
Well, contrast reduction on the side, sprinkle in. Nothing too fancy, but clearly it's setting behind a ball.
Did you say that was 22 miles?
22 miles, yeah.
322 feet of drop, just to get that straight. Good stuff.
Yep.
Go on.
Yep. And just before anyone sort of whinges, anyone who ever wants anything that I've ever mentioned on here, I can produce raw files for. That's not an issue. So if anyone ever wants to challenge anything that I'm saying or showing, it's easy for me to just produce raw files. So feel free to DM me on Twitter or wherever. Okay, so here is an example of the horizon moving closer to a ship or a boat. Now, when I say the horizon moving closer, is because I am the one that's moving up or down here. So on the left, I'm going to move from low to high, and on the right, I am moving from high to low. These boats are stationary. They are not moving. So as on the left, I go up, this one comes more into view, and the horizon appears to drop lower on it. And on the right, you'll see the horizon rise, or the boat rise. So we're getting, when I do the opposite thing, we get the same thing happen to them. So it's like a perspective thing that they are now doing the they're basically doing the opposite thing or the same thing when I move the opposite direction. Did I just confuse everyone?
No. So you went out on boats, you and another person, they had their boat, and you guys went basically horizon to horizon.
This was me on the land.
Gotcha. So
gotcha. Yeah.
Land, but like you had the land was like at the end of the horizon, right? Or the boat, basically. So you're looking at it from the water at different elevations. You're looking back at the land from different elevations. Got it.
Yep.
Yeah, we're looking at reciprocal function, one to the other.
Yeah. Yep. So this is a really good one because I read this in a book from like the 1920s when the dude was like, so suppose you had 4 boats out in the ocean, all at a horizon's distance to one another, as each one of them would see them higher or lower depending on where they're standing on the boat. And I was like, oh yeah, it's touche. But yeah, you just did that essentially with just using the boat, a boat and land to do it.
Yeah.
Yeah.
So
we created the exact same
well,
effect because they all can't be higher than one another, right?
Yeah, for sure. So when we look on the right-hand side, what we're doing by me basically dropping myself down, what I'm doing is I'm bringing the horizon closer to me. And when I'm bringing the horizon closer to me, that then brings the horizon closer to this boat. So now we'll see this boat climb higher and higher on the horizon. Now on the left-hand side, when you do that, what you're doing is you're extending the horizon and you're bringing the horizon closer to the ship. So what I'm saying here, by changing the heights, we can produce the same results for what happens when ships or boats move towards the horizon. This happens to ships, boats on either side of the horizon moving towards the horizon, or the horizon moving towards them. So it doesn't matter whether or not you mimic the horizon moving towards something or whether that thing is moving towards the horizon, you will get the same effect.
You're saying that
So
the
the
rate
effect
at
is
which
exactly the same thing on either side of the horizon. As any object moves closer to the horizon, no matter which side it's on, it will appear to rise up above the horizon. And we know 100% that this effect we witness on our side of the horizon. So when we're looking at that little boat, we know that when that's on our side of the horizon, it's just perspective. And I'm going to prove to everyone that it's just perspective on both sides. Now, this is actually just going from high down to low. And see how we get a perfect equal and opposite reaction from both of them? So now I'm just going from, this is at a high level, and now I'm dropping down low. And we get that perfect reaction that one goes up, the other one goes down. So it's just equal and opposite. So if we just look at it like that, this is what we get. Now, when you see a ship move away, now actually I'll jump out of here for a second just so I can do this. And we'll see here that we have this little part of the top of the sail there, which is what we would see. And we have the same part of the sail right here. Now, as this moves towards the horizon, and both of them are moving towards the horizon, both of them are moving towards the horizon, what we'll see is this. We're getting an equal and opposite reaction from both of them. They are both doing the exact same thing. There is no difference between these two things, except that because one is so much further away, it becomes much smaller. Okay, so here we have when just after I did all my other, like my previous lot of presentations, and I started introducing this whole idea, about a week later, I got this little orange sailboat that I caught in one of my cameras, and it just sort of stayed pretty much in range of the camera the whole time. It was just a stroke of luck. And now what we're going to do is watch what happens when it comes towards you. So as that sailboat's coming towards me, so it's moving away from the horizon. So at the moment now it's moving towards the horizon. Now it's moving away from the horizon. And see how both boats are moving away from the horizon, and they're appearing to sink from the bottom down. So they're losing, so they're disappearing from the bottom up, sorry. And as they go back towards the horizon, we'll watch them appear atop down. So that's, you guys sort of click onto why I've covered the boat there on the right-hand side.
Sure enough, either
So
side of a
just-
critical point. You bet.
So just here, basically what I'm doing is mimicking like as if this is actually going past the horizon. So like as if now we'll just cover it up. So all we're seeing as it gets closer and closer to us, it's actually dropping below the horizon, our visual horizon. We know that it's not physically dropping below the horizon because we're not retarded, and we can see it dropping below the horizon. But the same thing is happening here. It's just that we now have this massive wall of water, appearance of wall of water in front of us, because this is rising up to wherever our eye level is, or approximate. It wouldn't be at my eye level on this day, because this is an inferior mirage, and that will always drop the horizon. Which is why when people like Ruhif decide to show crosshairs, and not even counting the fact that he's got a ship in an inferior mirage there, that's going to drop the horizon, because it always will. 100% of the time, when you have a inferior mirage like this, it will drop the horizon below your eye level. And that's another thing that I will also show you. So does this actually happen in real life? This is a from one of Plain Truth's videos. Now he had, I can't do a pointer thing here, so let me just escape there. So this was his friend on the opposite shoreline, and he was on this shoreline. He had a friend on, they were both on either side of the shoreline. Now this boat here is this boat here. They're the same boat. From his point of perspective, because he's got an inferior mirage here, so he has this boat behind the horizon, and it is appearing to have dropped below the horizon. Now, if we look here, here is the horizon line right here. So this boat here is now also appearing to be below the horizon. But again, we're not dumb. We can see this boat. And this is what's kind of confused us. No, everyone's been looking beyond the horizon, when really what we should have been doing was looking in front of the horizon. This boat here is this boat here, and they are both seeing it the same. He's seeing more missing because this is an inferior mirage. So what an inferior mirage does all the time, 100% of the time, is bring the horizon closer to you. So now, let's say for this guy here, and actually these two guys they're getting different conditions on both of these. From looking this side here, I don't think this was an inferior mirage that passed the horizon here, but he had an inferior mirage looking this direction. So the conditions won't always be the same. But let's just say they were. If they were, this horizon here would probably be down here. The boat would probably still be in front of it, but it would be, this horizon would be lower and closer to this boat. It would probably look higher on the horizon. But if I just go like that, that's kind of what, you can see how the horizon is actually blocking that. So if we just put the water in there, that's what we'd be seeing. But because we've got the inferior mirage, he's actually seeing this whole bit here is being mirrored from there down. You guys are all up with that? That's all cool?
Mhm.
Yep.
Looking good.
Right, so here's one that I got. Now, unfortunately, it's very hazy for me, quite a lot. But this is the same effect. But we've actually got the two boats. I've got both of them here on either side of the horizon. So this one here is on my side of the horizon, obviously, because we can see the whole hull of the ship. And this one here is on the opposite side of the horizon. And then what people do is they go, oh, what are you trying to say that that's what we're seeing? Well, if I just place that little boat there, it doesn't really look out of place. If I just sort of move it over here, let's go like that, we could put this boat somewhere and it would just kind of look normal and small. Maybe not 100% normal because it's not actually in the same color scheme, but it's right there. It doesn't look unusual being on my side of the horizon. So when I've seen plenty of things where people are like, well, what are you trying to say that this is what's happening? You know, what, this is where the boat is? They're like, yeah, it's exactly what's going on. Because when we look at that, that's all it is. They're the same thing. But now we just don't see the boat on the other side because the horizon's in the way. And once it goes beyond the horizon, as due to perspective, because all of this is perspective, we see a little wave down here, a little wave here, everything rises up to the horizon. Once it rises, it now does the exact opposite thing of this, and the person on the opposite side of that has perspective going down. They're just looking back. This is me looking to my left. If someone was on the other side of that horizon, they would be looking to their right, and they would just be seeing this perspective as well, the horizon rising for them, and then that's what they get that. But they would be, for them, on the other side of the horizon, they would be looking at this. It would look the opposite way. So this one here would look like this, and this one here would look like this. They're just the same thing. There's no difference between them. And this is what people really need to understand. And I'm going to go through more of this. So I probably won't fully play this. I'll just cruise through this. But this was that little orange boat as it was coming towards me. And you see it just progressively get closer and closer. And that sail dropping below the horizon. So they're the same effect. There is no difference between the two, apart from the fact that one's going beyond the horizon and one's coming towards you. Right? So like I say, remind you of anything. The sail is disappearing. So we have the sail disappearing here. Why is that like that? Okay, it's going to stay. Oh, there we go. So we see the sail almost completely disappearing. And if that had have come more towards me, this would have gone completely under the horizon, mimicking the fact of like now it's gone too far beyond the horizon and we don't see it anymore.
Yeah, one of my favorite tricks has been when something's not visible anymore, it's going beneath you. That's such a good ruse. Just anytime you don't see something, oh, where is it? Oh, you walk so far away, it's now antipodal to you.
Yeah. But as we see here, this is clearly below this. It appears to be. But we know that this bit here and this bit here are actually on the same level.
I'd really like to see these two values quantified in ratio to the horizon line, like frames 10 and 10. What are their distances? You know what I mean? From each other for that matter, and from the actual horizon quote line. I think that would be interesting to see. I guess that's where science should head in the direction of next. You know what I mean?
Yeah, for sure.
To fully quantify that.
Well,
Yeah.
if you were to quantify it with formula, right, this is well within the range where parabolic, linear, and spherical would all be approximated by roughly the same. So even if there is a linear loss from the horizon, as you're saying, then it would closely match 8 inches per, like this is how they got away with saying that, look, when you don't see it, it's actually physical Earth curve at this rate, when literally it's linear perspective at almost the same rate.
Yeah,
Like
no, that's what I would say. So, and whatever height you are above the surface, you're still going to get that disappearance from beyond the horizon, because every time you rise up, the horizon extends forward, but still comes up with you. So you're still seeing it basically at your approximate eye level. If anyone wants to get triggered by that, then we'll just say, no matter what it rises with you, it rises with the observer. That it does that 100% of the time. That can't really be argued with, or I guess you can argue with it, but it's just a little bit asinine to really argue that point. And we'll go over that as well. Because it's just so obvious that the horizon rises with the observer. Like, I mean, I was just on a plane the other day. I was right by the window, and with the shutter up, my eye level was just above the shutter. I couldn't see the horizon. I just dropped myself slightly below there, and all of a sudden there it was. I put my eye line just above the shutter, couldn't see the horizon, drop it down again, there's the horizon. So when people say the horizon on a aeroplane isn't rising with you, it is. It is a ridiculous thing to say. So here we have a boat, sailing boat. It's going to go from one horizon, and we see it dropping below that white line, which is representative of the horizon, and now it's going to go to the opposite horizon. Now, it didn't completely get to the horizon, so we didn't see it fully drop below, because as you can see, if I go to about here, let me get out of there. Okay, I can't do that there. If I move this out of the way then now, And I'll just show you how it didn't actually quite make the horizon on the other side. So here, so you can see the horizon is still back here, or what we would call the horizon. This is obviously just where the land is. So this is seeing all the way to the shore. This is just under 10 miles away, and I'm at a 20-foot observer height. This area here is called Merino Rocks, and I'm on Grange Jetty. So anyone wants to look into that, you can do that. You can look that up yourself. Merino Rocks, South Australia, from Grange Jetty. And here's the shoreline right here. It's about just under 10 miles away, and we see the horizon is all the way back here. So this won't actually make the horizon, so it won't ever. What did I do? Went wrong way. Anyway, let's just go to the next one. So here we have a speedboat. It's just to the right of me, and it's about to go to my left-hand side. And again, I've covered it with water here, right at the horizon line. And you can see that when you cover it, all we can see is the top of it. Now, as we just let that play, you'll see the boat now rise up above the horizon. And this was a bit of a superior miraging day. And now as it comes back, we'll see it disappear from the bottom up. So just as anything else, when it moves away from the horizon, so at the moment we would describe this as it's moving towards the horizon, and it is appearing from the top down. And when it's going like this, we would say that it's now moving away from the horizon, and it is disappearing from the bottom up. So you see how that's why I put all those ships on at the start, because when they're moving away from the horizon, they're disappearing from the bottom down. And then when they're moving back towards the horizon, we see them appear from the top down. So you get the exact same effect of everything that's in front of the horizon to everything that is beyond the horizon. If it's moving towards the horizon, it appears from the top down. And if it is moving away from the horizon, it will disappear from the bottom up. So as you can see, we're basically just seeing the exact same thing. And this is not something that just happens occasionally. This happens all the time. This is not
when you say towards the horizon, you mean when it's coming towards you from the horizon?
Yeah.
Okay, got you. Okay.
Yeah. So if it's on the opposite side of the horizon, it's moving towards it. It's coming towards you, right? So when it's coming towards you, so if we go back to the other one, so just imagine like this is moving away. So the one on the right is, it's moving towards the horizon. So if you imagine the picture on the right-hand side, imagine like that's now moving towards you, and now it's going away from the horizon. So it's like as if it's moving away from you beyond the horizon, and now it's coming towards you. So as it moves towards you, you start to see it appear.
So when we do the math for 8 inches per mile square, we're supposed to be applying that at a rate at which you lose information past the horizon. So past the horizon is the point at which the loss is supposed to start. And that's when it starts to mimic, parabolic, spherical, or linear can all be the same under that 100 miles.
Exactly. That is the second equation. The first one you apply is your eye height level in feet times its root times 1.22. That tells you in miles how far away that line is. And then after that, you're supposed to compute 8 inches per square mile.
Cool.
Yeah.
But as you see as well, that same computation is happening in front of the horizon as well. So you see how it's dropping below you. So as you go up, everything directly below you, because the horizon now extends, you would have that same computation. So that 8 inches per mile squared in a way is also happening right below your feet, because this thing here, as it moves, as it sort of gets right to you, it's going to be now right at your feet level. So it's going to be right below your feet. So obviously the bottom of the boat, if you're at, I'll just say 20 feet surface, the bottom of this boat is 20 feet below you. The top maybe is like, I don't know, 10 feet below you or whatever. Maybe this is 10, 12 feet. So that's, 8 to 10 feet below you. As it moves closer, then we'll start to see it. Actually, I don't know how tall this boat is, but you get what I'm trying to say?
Yep.
You guys on that? So basically, because you've risen up, you have that same thing as from beyond the horizon as you have in front of the horizon. So this is a sailing boat. So we see it in the inferior mirage, and as it gets closer. Now also, if I was to, what was this one? So this, that's not what I wanted. No, that's the next one. Right. So if I go right here, so see this buoy here? So this is 3 miles away. In the one that we just saw, all this land here was visible. You could see the shoreline down there before. Now this is only 3.6 miles away. This land is closer to 10 miles away now, and now we don't see any of the shoreline. It's because this horizon has been brought closer to us, and now the horizon gets brought closer to you. This is where my perspective ends. My personal perspective ends at the horizon. So once something reaches the horizon, it will now appear to disappear once it goes beyond the horizon. And this point changes. And that's why I'm showing this, because here we have this one here at 3 miles, or just over 3 miles. It is, if it went beyond that way, we would see this whole thing disappear. But on the other day, you saw well beyond here, when you can see the shoreline, this isn't going to disappear anymore. You would see the entire thing. Now, as this gets to the opposite horizon, now you'll see it start to disappear, right? So we see this now disappear. This is just purely perspective on the opposite side of the horizon. Now, yesterday I did a little thing where me and a friend were on both of the jetties that I normally go to. So we'll see that jetty just. Did I not put that jetty in there? No, I didn't. Okay, doesn't matter. Let's just skip. Actually, this isn't. But yeah, so here's another one. I'm just trying to put together the case of like this happens all the time. This is not something that it's identical to what we see of everything going beyond the horizon. It happens all the time, every time, without fail. It is 100% thing. It's not like cookies. It's not a sometimes food. It happens all the time. Right. This one was good.
Thanks for documenting Earth curve, silly flare, for whatever, you know.
Yeah. So this one went perfectly to the horizon, almost like I planned it. Turned around, came back, and then went to the opposite horizon. Now, did I put the jetty in there? No, doesn't matter. We'll get to it.
Is what is it, jetty? Is this some Australian slang you're throwing at us? Is this some new thing that just
boardwalk?
came out? Okay, I got you. The pier?
You guys, yeah, pier.
Okay,
you
okay.
guys-
The jetty. See, when you kept saying jetty, I'm like, oh, he's out on the jet ski with the boys. And I see you station, and I see you not on the jet ski with the boys, and I'm like, I don't
What's going on?
understand Australia.
He's over at the small circulating pool of water somewhere. That's what that is.
Yep. So here we just have this person here, Steve Bruick. I don't know who he is. He's not a flat earther. He just happened to have a camera that was catching all these boats. So I just thought this was pretty fitting. You can see just the sails are all above the horizon. All the little boats are all below the horizon. So you can just imagine that at the exact same distance on the opposite side of the horizon, the only thing that you would be seeing are these little sail boats, like you'd see the top of the sails. All these other boats cruising around, everything else would be completely out of vision. And it's all just perspective. We know that it's perspective in front of the horizon because, again, we're not dumb. We can see it. It's right there in front of us.
Yeah, but when it hits that horizon, dude, that's the hard ball line. It's like a knife edge, but super round.
100%. It is completely not round. But yeah, so all we've got here is, this is why I call the horizon is the dividing line of perspective. So we have perspective on one side of the horizon and we have perspective on the opposite side of the horizon. And once it reaches this is going from low and appearing to go up. Once it hits the horizon, it now is going from high and then appears to drop back down low. This is all that's going on, and that's all I'm making a case for this whole thing. That's all this is about. So basically all I do is just block it right at where the horizon line is, and the only thing that we see are the sails. All we see are the sails. We don't see anything else. So this is all that someone is seeing from the opposite side of the horizon. And in fact, they probably wouldn't even see these sails because they'd be so far away. They'd probably be tiny. They'd be like little dots.
Yeah. When this plays out, can you go back to the still image at the beginning of this that you were showing? Not that one, the other one. Yeah, right here. So like if you look over here at the island to the far left, and then like if you were to draw a line from that island to the horizon, you know, it would be a much larger. It doesn't seem like it would be that much different of a line than the one that's towards the middle of the screen, because if they kind of look like they're at the same depth, but you can see from the distance between them to the horizon is actually, you know, it's a large distance.
That's a
Discrepancy.
substantial amount.
Yeah. But they look close together at the horizon because they're compressed, you know, as that
For sure,
you know,
there could be a mile in between them.
yeah, as part of your perspective. So like as everything gets out, you know, it's all like you were saying, you know, you would just see these really tiny sails from a distance, but that's just you're just looking at the other extreme of the effective perspective, like you've been saying. It's just a really good shot there, because it just you could tell that there's, you know, depth between these two, but you can't really tell how much, but it's significant, because when you look at the horizon where it is compared to that, it's actually above. It looks like it's above the island, and we know that the water is not above the island, because then the island would be underwater.
Exactly. And also, when people draw perspective grids, and even the ones that I've drawn, no one ever really draws them correctly, because this island here, it's probably only maybe a kilometer away, you know, half a mile. The next one is probably like 2 or 3 miles away. And this horizon here could be 10, 15 miles away.
Yeah, it's out there.
From here to here could be
Right.
like 12 miles. This little distance here. So when you, like I asked chat, I'm like, oh, when we're looking out towards the horizon, what's the ratio of how a perspective grid should really be drawn? And literally like 80% of this to 90% of this should be the first like 1 or 2 miles. So if this is 15 miles, the first 80 to 90% is the first couple of miles. The rest of it is all compressed into that little part.
Yep.
Which is something, you know, and that's why we get compression. And also when you have a horizon that's closer to you, due to say something like an inferior mirage, and then when the horizon gets pushed further away, now you see an extra 10, 15 miles, whatever it is, that's all getting compressed into that tiny little section. And that's why we get full compression, because your entire perspective of how you see everything has to change, because now you're seeing further.
I was
So when you have a 3-mile horizon,
I was just graphing that in my head, actually, and what came to mind as a parallel is the time dilation effect with velocity.
Yeah,
Right.
B squared over C squared. It's that sudden for so long and then that abrupt at the end. You know what I mean? The ratio is very similar in terms of
yeah,
curve.
yeah. Shane used to have some great like the logarithmic scaling for optics for distance. Like there's like that linear portion, and then as you get further out, it just takes off.
As you approach the horizon, the compression like approaches infinity, right? So it's not really, it just hits that curve, and eventually everything that you know is compressed in that little tiny bit. It's a tough
Yeah.
thing to explain.
Yeah. No, it definitely is. Now, I wanted to just check, is perspective a law? Because it should be. It should be a law because it's something that happens 100% of the time without fail. But they only use it really they basically just claim that it's really something that's done for art. But it's not really just done for art. It's how you see the world. There is nothing that you don't see in perspective.
No, you see the world through globe. You replicate it through art using perspective.
Now, where was it? I'm sure in here somewhere. Artistic rules perspective apply to drawing and painting and appearing in a current depth and distance. Illusion is a method to create the appearance of a 3D world on a two-dimensional surface like paper or canvas, basically saying how to create it over a flat surface.
I think if you were to quantify, it'd be like projective geometry, right? That's where you'd find perspective, I think, adequately mapped out, even on Wikipedia.
Right, yeah. So, I mean, it should be a law because at the end of the day, it's the entire way that you see the world. There's nothing that we can see that we don't see in perspective. So I'm just going to go over a little bit of that. So this is one that I presented before from Vortex Pup. Their talk that they did called The Great Switcheroo. Now here, what we have to think of is, what is this? Why is it doing that? Why is it that this one appears to be lower than this one, which appears to be lower than this one, and so on and so on? Like, why does that happen? So I just sort of point there on this one here saying like, this is a general perspective grid of how they're normally drawn, or they're drawn over the entire page. But really that's where the first like 1 mile should be. So this shouldn't really be, let's say each one of these represents a mile. It shouldn't be like that. Really, it should be one of them is all the way up there, and then they start going from there. But it kind of messes with you a little bit. If you're going to do that, you're not really going to be able to draw too much in those tiny little pieces. And that's why we get so much compression. But so what we really need to ask is, why is this one lower than this one? Like, what is this? Why do we have that? All right. So let's just imagine that there you are. You're in a helicopter. We've got a insanely flat day. There is just not a ripple on the water. So you're on the beach. You're in the helicopter. We've dug a big hole and we put your eye line so perfectly in line with the water and everything that you do not see any surface beyond that line. How are we going to create perspective? How are we going to create a horizon that's at a distance from us? Get some feedback?
Got to reverse it and have use the sky.
Yeah, but so to get it over the surface and the ground, how are we going to get to be able to see perspective on the ground now, so that we see the apparent rising? Okay, all right. So what we need to do is, from here, we see how this rises. How are we going to get that to happen? How are we going to get this to happen? Basically, what we need to do. Oh, hold on, I forgot I added this bit. So if I put all of these there like that, they're going to appear like they're all on one line. Now, obviously, as I put forward, once you get to a horizon, everything from beyond the horizon will start to drop. But let's just pretend that we have no refraction. We can just see for miles and miles. Even just we just don't see the surface. We can just see everything on the surface. The way that we're going to be able to get the surface in the first place. Wrong. Yeah. Why am I going to? What did I do that again for? Silly me. Is we have to rise up. So what I'm putting forward as well is that the only reason that we have a horizon in the first place is because of your height above the surface. And that's why the horizon is different for every single observer. So obviously, if you've got a toddler, your toddler's only like 2.5 feet tall. The horizon for your toddler is at a different position than the horizon for you. If someone's in a 2-story house above you, the horizon's in a different position for them. It is literally your height above any surface that creates perspective, but it's your height above the surface that creates the horizon for you, because everything is designed in this realm for each of us individual pair of eyes. Because I never see what you see and you never see what I see. Even if we're talking to each other right next to each other, we're still looking at different things. So our perspective of what we see is different. So again, you're here. The only way that you're going to be able to create a horizon in the first place, because your eye line is right where the horizon is. So you don't see a surface. The only way to create the surface is to rise up. And now you will get perspective. You will get this ramping up of the horizon, or this apparent ramping up of the horizon, because we know the horizon isn't actually doing it, but it appears to.
That was
And then-
that was a great demonstration. That really sent it home. The looking at it again with the guy in the thing, yep, right there. Yeah, that rising up to create it. That's great.
Yeah.
This
so
is
that's what
essentially vertical parallax. That's what we're looking at there, right?
Yeah, it is in a way. Yeah, that's definitely one way of looking at it. So basically, what creates the horizon in the first place is your eye line above the surface. And then from there, the horizon, the position that the horizon will be in is there because of refraction. So it'll either be further away from you or closer to you because of refraction. But the reason that you have it in the first place is because of your height above the surface. That's what creates the horizon. That's why there is a horizon. And I'll show it in a minute. But so as you go up, when you get to a cloud layer, once again, you're right on the clouds. So you don't see any clouds beyond that. The only way you'll see clouds beyond that is to go up until you get to the next cloud layer, and then it would repeat. Right? So that's basically what you'll see as you go up and down. So as soon as you hit the cloud layer, there's no perspective anymore. Perspective
really cool.
disappears.
That's a really cool demonstration.
Right? So, and then thank you. And then we go into,
is it all sky or all ground? That's a great, you know how they're like, you can't have a horizon on a flat earth or whatever. It's like, so is it all sky or all ground? And what you made is a great way to represent, like, we don't see that. So that's clearly not it. That's awesome.
Yeah,
man.
Sure. And then, so when we look at planes going down, they're about to go into the clouds, like, so drop below the clouds or so, we see that horizon line, we see a perspective all disappearing. And we're getting right. It didn't quite, this one, the video didn't quite go into the clouds, which is a bugger. It would have been perfect. Right. But you see exactly what I'm talking about. As it drops down, all your perspective is changing. It's getting less and less and less until you would be on a perfect horizon line. Right. And now we look at this one here. We're looking through a tunnel, basically. We see everything from high dropping down, and we see everything from low going up. Right. This one's just breaking out of the clouds, the one on the bottom left now. We see a complete tunnel of everything above you again. Now, this one here, obviously, we're now way above the clouds, the cloud layer, but that bottom cloud layer is just the ground. You just got above the ground, and now we have perspective. Imagine that that's just the ocean, or that's a flat plane, you know, and then the cloud layer above is the clouds. You can just replace that and put instead of the bottom layer being the clouds, you could just say that's the ground, that's water. And the upper layer is clouds. It's exactly the same thing, because all we're doing is seeing perspective. That's all we're doing. As soon as you rise up above a surface, you get perspective, and it happens above every surface. Now we're even further above on the right-hand side. So we have a much greater distance that we see. We have a cloud layer that's way higher. So we see perspective going down. We see perspective going up, everything below us. So it's all the same thing. And this is the point, is that perspective is the way that we see. There is not a thing on this earth that we do not see in perspective. So here's just a little thing that I did out in my back, in my kind of little tool shed thing. And as you drop down, perspective disappears. And as you rise back up, we now see everything again. When I got down to that bottom line, this is only a 3-meter distance. See that little thing in the background there? See this little thing right here? This is only over 3 meters. And right when we lose perspective, it disappears. So if I go like this and then go to here, so you see how we can still see this line here? So this line here is this line here. It's still visible. So that means that we're still above the surface.
But look, if I watch the sunset and then I go up a tall building and I see the sun again, that's only because Earth is a globe, right? That's one of the biggest globe proofs that I've ever seen. You tell me that you can do the same thing on your table? That's crazy.
Yeah, no, it's insane. Now see how
What's
we
the
can
radius
still see
of
the
that
line
table?
Here? Yeah, so it's about 3,000 miles. So we can still see perspective here because we can still see this line. So we know that we're still actually looking at the surface of the table. We go a bit further. This is starting to drop away there, but we can still see the line here. So we're still actually seeing some of the surface of that table. And this is dropping away. And then right when we're getting to here, now it's disappeared. Now here, this becomes a line in front of us. This one here was about 1.8 meters away. This was 3 meters away, actually 2.97 meters away. And in 2.97 meters, we lost about 4 millimeters. So that these lines, that little thing, and there was a line above there is about 4 millimeters high. So at just 3 meters distance, we lost 4 millimeters behind the horizon. And then if we just reverse it, if we just reverse it and now we pretend like we're going up in the cloud layers, as we go up, everything, if there were things there, it's just like what we saw. As you go up, now everything disappears and perspective will just reverse, and it's going from everything from high to low now. So it is just how our eyes see. There's no way around it. And that's why this should be a law. I don't know why it's not a law, because it's something that happens all the time, every time, without fail. But as you can see, the reason that it happens is because of your height above the surface. Because also the reason we see further in the clouds and further across the clouds is because technically, imagine if we flipped that image and we had the ground, and we had to say that the ground was. Okay, click on there. If I arrange this and flip the image, and now we turn this into the ground, right? Now this goes up in the distance, and this one goes down. So if you just flip the image, we get the same thing. And if you look at this is like perspective layers, right? It's like a grid. We're now looking at just perspective layers going up. So this is like as if we're now, when we're on the ground, we're a few thousand feet below that. So therefore the perspective of it is we see further. If you imagine now you just went to the cloud layer, now instead you won't see as much clouds. You would see way less clouds because you're closer to the clouds, and you'll see way more land because you're further above the land. Like, it's not rocket science. How it's eluded people, or these, it hasn't eluded us, but for some reason the people on the opposite side of what we believe have a complete mental block because they've got balls in their eyes. So again, no matter where we look, we see in perspective. Everything you look at. So you look at everything going down this direction.
It seems
you turn and you look this way.
intuitive, but it can never be acknowledged because then there would be resolution.
Yeah,
Right.
for sure.
So they're just like, I don't understand. It doesn't work. They're, can't work on Flurf. Like it can't because it leads to resolution.
Yeah, and it doesn't matter which way you look. So if you were to look this direction here, and we looked at all these little dots on the pavement or the road here, you would go, this one is lower than this one, which is like visually lower than this one. If we were to draw lines, each line going up here is going to get progressively higher. And if we went over this way, each line would go progressively higher this direction. If we look in the middle, it goes this direction. It's 360 degrees around you. Right? So it just works everywhere. Like, the only reason that we even know that those windows are above us is because of perspective. Right? Because the way that we see everything, the way that we see the world, we see everything in this fashion. There's nothing that we do not see in perspective. So it's just my desk at home, and when I'm looking straight at it,
Perspective of the perspective. I like it. Very meta.
yeah. And then I turn that way and I look that way, and now everything on that direction is going up. And if you were to look on the floor, if you were to look down on the floor, this one here is lower in the picture than this one here. So that's telling you that this is going this direction. Perspective tells you every little thing about your world and exactly how you see. Right? We look this direction, and now we see everything that way.
And we're having a sale on cameras tomorrow. Come on by.
Yeah. I do have a bunch of cameras for sale if anyone wants to buy one. But so here's a nice one. This is 4 different days. Okay, 4 different distances to the horizon. Can someone tell me which one's further and which one's closer?
Ooh.
It's just not possible, is it? Like, how can you tell that? You can't tell it. You go out there and you look at the horizon, and unless you've been out and you've looked at that area hundreds of times, or it's an area that you look at and you've gone out there with an actual camera and you've really looked at it, you would never know which day you have a further horizon and a closer horizon. Like, it's just not something you're going to know. As an ordinary person who's never been out there and looked with a high-powered zoom camera over and over and over again, you're just going to go out, you see the horizon, you go, oh, horizon looks beautiful and clear. And you're just going to go, yep, look at how clear that horizon line is. Okay, so this is looking from one side to the other. That's right, I'll just get out of there now. So now everything on the right here, this is me looking from Grange, and this is Brighton. So from Grange, I always turn and look towards Brighton, and the first part here is that's looking towards Grange. Oop, yeah, what happened there? Okay, it doesn't matter. Okay, I got it here anyway. So now we see, I'll just get out of there so I can use this. So this is looking towards Grange, and this is looking towards Brighton. This is Brighton here. This is Grange here. So on this day, and this is where I'm going to show you how the horizon changes and then what that does and how that affects our perspective. So here we have a horizon on this day that's approximately 3.5 miles away. These are 2.5 miles. These are 5 miles away. And that's where the mirage is. So your horizon line's here. So I'm saying approximately 3.5 miles. This is Grange Jetty here. This is one called Henley Jetty. So here on this day, we have about a 3-mile horizon. This side here is me looking towards, this is Brighton Jetty. These are those same poles. That's why I've got them connected here. They're the same poles there. These white ones here were the same ones as over there. They're 3 miles away, and the horizon is basically right on them. Maybe ever so touch in front of them or dead on them. So we've got approximately about a 3-mile horizon there. So we've pretty much got an identical thing looking from one to the other, even though I was 2 hours apart. So when you look one direction, we see this, and now my perspective ends here. I don't see anything beyond that because the horizon was created. And the moment a horizon is created, and the horizon being the dividing line of your perspective, everything from beyond that horizon now will start to disappear. Same goes here. So then we go into the next one, which I'll just skip through here because I'll stay like this. Oh, wrong one. Okay, and then this was on the same day. I've now gone to this area just over here, which is called Kingston Park. It's looking from here, so looking that direction there. And there's Brighton is just over here. I put Glenelg there, but anyway. So Brighton is just here. And now we're looking this direction here. And this is Glenelg. And Glenelg is 4.2 miles away. If I zoom in on that, you'll see that The horizon is just in front of these rocks here. So looking from Kingston Park, it was closer to a 4-mile horizon. So conditions aren't always identical every single spot that you're in, right? So we can see how my perspective ends here. And this was looking from Brighton towards Hallett Cove. And this was at about 4 miles, as again, there. Now, this is 2 days later. So this is the 12th of September. This is the 14th of September. And now we have closer to a 9-mile horizon. So now these are the ones that were in an inferior mirage before. And we see here, like, look at this. This is 8.5 miles away. That's 8 miles away. And these ones at 5. So between here and here is 3 miles. So that tiny little gap right there is 3 miles. And this is where the horizon was before. So if we had the horizon here, so if I just quickly do this, let's get that straight. So if I was to put the horizon there, see how much lower that is, perspectively? That's where the horizon was before. Was at this point just here. All this was gone. We couldn't see any of it. So now our perspective has to change. Everything about your perspective will change, because before, if we were to draw a perspective grid, it would have only gone to here. But now we have to extend the perspective grid further. And I'm going to go over some of that as well. All right. Where did I go to that one? Okay, so this is just looking at the two different things. So here we have 9 mile day. Let's just go here. So you can see on the bottom left, and on the left-hand side, we've got looking towards Grange, and we're looking at both days and how we have a completely different perspective of what we're seeing. Right, the horizon line is lower on the bottom left and higher on the bottom right. So on the on the top right. So on the top right, that horizon line is much closer to my eye level, and on the bottom left, that horizon line would be below my eye level. And then looking on the opposite side, we're just seeing the same thing, but looking from the opposite direction. Right, now, this is just me. I just mucking around doing this for something to do. Now, this little horizon line that I did here isn't a straight line. It's actually a circle that comes back towards me, and I just extended it out to so that it was something like 50,000 pixels, and it created a straight line. So even though this is a circle that's coming back around me, it still is going to create a straight line.
Oh, that's awesome.
So, sorry, did someone say something?
No, I said that's awesome. And I like that you made your own jetty for the image. That's awesome. A lot of detail went into this. Respect, dude.
Yeah, I just muck around. Sometimes I'm like, I'll just do this. So the horizon is a 360-degree circle around you. We all know that. Okay, and in fact, in reality, it's not always a 360-degree circle around you, because you might look to the left and you have a 3-mile horizon, and you look to the right and that horizon over there could actually be 12 miles away. But let's just say, in general, we'll call it a 360-degree circle around you, because it basically is. Now, that visually appears to rise towards your eye level. It can appear slightly below, it can appear slightly higher, but it always appears to rise with the observer. Now, if anyone doesn't think it rises with the observer, can someone please tell me, what am I doing right now? And if you don't like it that way and you want to see the jetty drop instead, does anyone know what I'm doing?
Is this a drone?
No, this is me with my camera. So
You're just holding it higher?
You're getting pretty high there.
Yeah, because I'm on the, here, I was about 1 or 2 feet with my camera, and then I just put the tripod up a bit higher. I put the tripod up a bit higher, a little bit higher again, and then I moved back, because further back the sand goes up higher into sand dunes. So now I'm on a sand dune, and then I went higher on the sand dune, and then I went to the highest sand dune. So we see the horizon rise as you rise. I mean, who would have thunk it? As you lower yourself, the horizon lowers. As you raise yourself, the horizon appears to rise. Now, again, we're not R-worded. We're not retarded. We know that the horizon isn't actually rising. We know that it's still down, in this case, about 35, 40 feet below me. But we get this apparent rising of the horizon, because the horizon is the furthest point that you can see the surface. So it's your eye line, it's your eyes, your personal eyes create the horizon. Now, if I was to escape out of this picture here, this guy here, his horizon is not going to be up here. His horizon is going to be down here. This guy here, well, there you go. Look, now all of a sudden, his horizon is going to be here, right at this point here. So where I am right now is obviously just slightly below where his head is. And now here's our horizon. So when anyone sits there and tries to argue this whole point of the horizon doesn't rise, it's and the only word I have for it is retarded. I don't really know any other word for it. Can someone think of a nicer word?
I would go with geometrically challenged.
Geometrically challenged. Okay.
No, Aussie retarded is almost like Boston retarded. I'm a fan. So.
Forget about it. You're tired.
Sounds very
Totally.
hard.
Yeah, Braz, you're retarded. Yeah, so it's just ridiculous. Like, in arguing this point with people saying the horizon rises with you is just is insane. Because we can look at this right now and we can say, well, does that boardwalk of the jetty appear to be above the horizon, or does it appear to be below the horizon?
So if I agree and tell you what it is, that would lead to resolution, and that can't happen, my guy.
Exactly. So they'll argue this till the cows come home. Well, it's not rising with you. Well, then what the hell is it doing? What the fuck is that?
It's perpetually a function of observer height. That's what you keep showing over and over and over again. The observer height determines everything. And when you start to apply math to it, what do they always ask you? Like whenever they make an observation that can't happen on globe Earth, they're like, well, what was the observer height? Hold on. How far away were you? Okay, well, here's how much refraction there obviously was for you not to see that on a globe. So they retroactively plug it in like to bring it back, right?
Yeah, for sure. And it's like if we look into angular resolution and Rayleigh's criterion, obviously if we had zero refraction, then the horizon would still do this. It would still rise up because it's a function of your eye level, but that would just be many miles further, right? Because it's not until we actually hit that angular resolution is where we would then see the horizon. But it would still get created, even if there was no refraction at all. We would still have a horizon because we don't see in orthographic view, we see in first-person view. And that first person is predicated on your eye level. So wherever your eye level is, that's the furthest point you can see.
This is where I hear the Globies interject a lot about with refraction, like you just mentioned. And for me, it always brings to mind the orders of magnitude we see in dip chart corrections. You know what I mean? For sextants and otherwise seafaring craft if you're 6 feet over the water, if you're 20 feet over the water, there's a correction there in terms of where the horizon is supposed to be viewed at. But few people actually take a look at the chart and understand that those corrections are effectively of the close order of magnitude of a handful of arc minutes.
Right.
The diagrams
And
get you.
what you're showing here is massive changes in perspective to do with elevational perceptual angle, that kind of thing. The point is that there is no change. You're just seeing the same thing at a different incident angle, and there literally is no correction to make. I mean, when you come to the practical, if you were standing on the deck of a ship with a sextant, and you're looking at the horizon, and you're setting your mirror, and you're trying to get it, the boat's doing this the whole time. You know what I mean? The boat is just, but the correction is the merest fraction of a single degree, and you're trying to get your reading. What's the point of a correction chart when that's what you're doing with the tool? You know what I mean?
Well, and also when you think about it, like what is that horizon you're looking at? Is it a 10-mile horizon? Is it a 20-mile horizon? Like maybe right in the middle of the ocean, the refractive conditions are very similar all the time. I don't know. But I would assume that they would even still be different. So some days you would still even see further, which obviously you do because there are all those stories about supposedly seeing ships many miles beyond where they thought they should be seeing them.
Well, I agree that with the dip chart, the only variable there is your height above the water. And there's no mention of anything to do with atmospheric condition, temperature, humidity, or otherwise about what's in front of you. Is there a cloud deck in front of you? None of this is on the chart. I just so conspicuously weird.
Yeah, for sure. And so here we have, this is from Jesse. I should have put his details up there because I normally do. Sorry, Jesse. Jesse Path of Light, everyone. I think it's just Jesse on YouTube. So on the left-hand side, he's looking at something and he says that an eye level that's 28 feet above his eye level, and the other one's 20 feet below his eye level. So to sit there and argue that the horizon isn't rising with you, it's just ridiculous. It's like how they go, well, the crosshairs are always above. Well, they're not. They're not always above the horizon. Here we have crosshairs with that have to be raised to 28 feet above his eye level. Right, so it's just ridiculous to even bother using a theodolite in a way to argue that the horizon is dropping, because it's not always dropping. It just depends on the conditions of the day and how far are you seeing. So Swala did one a while ago, and he was like, "Oh, look, see the horizon's dropping below my crosshairs." And as I skip through and I'm looking through his video, and just lucky, right where he put the crosshairs and all that, there was a ship there, and that ship was in an inferior mirage. And I'm like, "Dude, you got a ship in inferior mirage. The horizon's obviously going to be lower." And then he started going off, "Oh, everything's an inferior mirage for you." I'm like, "Well, then stop showing me shit in inferior mirages."
Stop showing me them.
I see a bigger issue here, and I actually produced a video on it in response to some of the garbage that Jesse put out. It is that people like Jesse are simply, they have no cognizance of the term fit for purpose. A theodolite is not fit for this purpose. It's just that simple. He has put out videos where he's got the same piece of hardware. I recognize the readout, and he's hitting targets that are 105 miles away, such that when he sets up his tripod and stands in front of it, and there's a camera over here, say 10 feet from him or whatever, shooting him at normal zoom, you can't actually see the target in the background. It is the atmosphere in between you and the target has completely obfuscated it, and you only see it once you're looking through his zoomed theodolite. not fit for purpose.
Right. Yeah. And we see here as
Isn't
well.
misusing a
even within-
theodolite how the ball was born, though? Like, I feel like if they were to pick from
Pretty
canon, it
much.
wouldn't work anymore.
Yeah, we have a classic example here of why can't I see forever? Like, I mean, look at the left image where it's still hazy. With the right image, it's even more hazy, so you see less of that image. And I could show ones where the hills that I'm always looking at in the background, they're just gone. You can't even see them. Where
Yes.
on a clear day, they're bright as day. Where I've literally got days where it is so hazed out, you cannot even see the outline of the hills that are 30 miles away.
Yeah, earlier you mentioned how the horizon is created, and even if there was like a clear day, like you were saying, there's a thing called contrast reduction. So just how much light gets scattered in general going through like regular air molecules, that's going to also create the same, that's going to create a horizon for you as well, where the sky and ground are going to be indistinguishable from one another. They're going to become white and opaque, and like the same effect that creates like the visibility factors, the visibility index, like that's what we're looking at here. Different factors affecting, like that's why the coloring is different from the other one. There's more atmosphere conditions going on in between the observer and the object, and there's more contrast reduction. So like it's just mechanistically what it is.
Yeah, that was that paper that you showed, wasn't it?
You are referring to Rayleigh scattering.
Yes.
Incoherent
scattering specifically. Coherent
That's
scattering would be the refraction, lifting the image up 1-to-1 kind of thing, and then the incoherent would be the loss of information. Yeah, but yes, the scattering.
Yeah, and that's like when you're up in a plane and you're looking out towards the horizon. 90% of the time it's just fuzzed out. And how do you know whether that's like? I mean, if it's getting fuzzed out, it's almost like as if you're putting a layer of haze in front of it, or like a fog or something in front of it, and that's going to bring that horizon closer to you.
That's that sweet geometric ball, baby.
That's sweet, sweet balls. We love balls. So your height above the surface is what creates the horizon for you. We've gone over this, and this creates what I'm calling a cone of vision, because this is what happens, right? I'm kind of skipping through there, but let me go here. So this creates a circle 360 degrees around you, and this is what creates your perspective, because we have this upward thing to your eye level, wherever your eye level is, wherever your observer height is. And this is for you in relation to the horizon. And all objects that are close to you will appear lower in your vision, and as they approach the horizon, they will appear to rise until they reach the furthest visual highest point in your vision, which is the horizon. Once it goes beyond the horizon, moves away from the horizon, it will now do the exact opposite and visually start to drop below the horizon.
That's a great diagram, man. That's a nice one.
Now, thank you again. So this is where I'm putting forward this whole thing of like, basically what we're seeing is in a cone of vision, because when we go back to here, because where our eye level is and where our feet are, wherever that is, our feet is like the bottom point of the cone, and way out there at the horizon, it's going to be appearing to rise up. So when you look in a 360-degree thing around you, you appear like you're in this basin. And I think this is kind of maybe where the concave earthers are getting a little bit confused in a sense, because really it kind of does appear like you're in this basin. And you've got this thing that's 360 degrees around you. So if you go up, like obviously extremely high, and here I put it for a 6-foot observer, and I've just put many miles because who knows? It could be anything. It could be 3 miles. It could be 30 miles. And for a 50-foot observer, now your cone gets bigger, and it's just many more miles. You go up to 500 feet, and it's even further. So every time you rise up, this expands, right? To the point where you're basically like this every single time you rise up. But these things are the same. That point there, every horizon is technically zero. But when it's there, when you're looking at it at this height, it's now not technically zero for you. It's technically thousands of feet, possibly above the surface. Zero will still be down lower. So that's why perspectively, if you're 1,000 feet above the surface, when that thing rises up to you to get to your horizon at 1,000 feet, for it to reach the kind of 0 point in inverted commas, it's going to have to appear to go down again. And its 0 point is technically 1,000 feet below you. So it's going to drop below you 1,000 feet when you're at 1,000 feet beyond the horizon. Did I just make sense then, or was that a bit confusing?
No, you're good.
Yeah. And so here we have, as you move, this cone of perspective moves with you. Everywhere you go, you create a new cone of perspective. So everywhere you go, your horizon moves.
Are you insinuating that there's a radius of vision that's observer dependent? Is that what's happening here?
How dare you insinuate you can't see forever?
Yeah. How dare you? How dare you?
Yeah, it's a moving reference that changes exactly the same way that vertical does when you move.
Exactly. And now,
Not unlike the Fortnite guy flying as we started with in the beginning, right? You talk about Fortnite, the dude who flies in, and everything gets rendered around the observer-centric system in exactly this linear capacity. So,
yeah, exactly. So here I'm on Grange. So I'm going back to some of these observations here. So here I'm on Grange, and I'm looking to my right now, and that little rock wall thing there, that is the very tip of that is 3.6 miles away from me. And if I was to zoom in on that, you would see that the actual mirroring starts just in front of it. So I'm saying the horizon's about 3.5 miles away there, right? And then we're looking back again, And so this is the 17th of September. And now we have a 3.5 mile horizon there. So now I'm looking to Glenelg Jetty, right? So Glenelg Jetty is further to my left as well. Looking, and you can see there, this is a Grange Jetty. Oh, let's do that. So that's Grange Jetty there. That's Henley Jetty, right? So now again, we have a 3 mile horizon. So as I move, the horizon's moving with me, right? So it's going to keep going with me. Everywhere I go, it's just going to move further. So now the horizon is coming to here. When I'm looking from Brighton towards Glenelg, see how the horizon's starting here, and Glenelg is 2.5 miles away from Brighton. So now the horizon is starting just here because we see the mirroring starting to happen here. So that's where we know the horizon is right there. And there's a tiny little bit of mirroring still back here. So we know the horizon is there. And then we move to Kingston Park, and now the horizon's moved again. It's in front of Glenelg, and from Brighton it's here. So the horizon is moving with me as I move, right? So this is what just happened. I'm here at Grange, and this was my furthest part of my vision, and then I could see to those markers. That was my circle right there. But when I moved to Glenelg, now my circle was here. I could see just the kind of Henley Beach. I couldn't see Grange because the horizon was in front of Grange. So it moved here. When I moved to Brighton, okay, then this became my horizon now. So as I moved, the horizon moved with me. Right? And now on this day, because now we have a horizon that's closer to 9 miles away, I only went to 2 locations because there's no point going any further, and now that's my horizon. All those spots are now in here. Whereas before this took 3 different times to be able to get the horizon going all the way across. Here we have 2. So now we have a much greater horizon. My circle, my cone of vision grew. And all it is basically just refraction. I would say the light's just traveling straighter, further on this day until before it starts to bend. And I would say that light is terrestrially bending upwards, and that's what's creating our horizon.
As far as the graphic itself goes, you might want to redo it in case you want to present this again at some point. Take all those red lines and make them something that's higher contrast to black, like a nice bright cyan or something.
Yeah.
And they'll be a little bit thicker, and they'll be more visible. Yeah.
Okay, it's not quite thick enough. Cool. You guys can't see it properly?
It's fine, but
It's
more
you have
contrast
to
is
really
not a
look
bad
at
thing, I
it.
guess.
Yeah. If the reds were a nice bright cyan and a little thicker, that would.
So this one here on the left is better?
Yeah, the yellow is definitely more visible against black, right? For sure.
Okay, all right. My mistake. My mistake.
We'll let it slide this time, but like 2 more of those and you're out. This is like baseball or whatever, or cricket, I guess, if you're familiar with the jetty terminology.
Doing the 3D grid of perspective downward to incorporate the cone of vision is a nice touch. I
Dude,
really dig that.
It's awesome. It incorporates the height up factor of it. I love it.
Yeah. And so here you see on different days, we see different distances, right? The bottom left and top right, clearly we have an inferior mirage. It's a close horizon, closer than 3 miles on both of those days, or probably around 3 miles on both of those days. And then on the other days, we have horizons that go anywhere up to possibly 20 miles away, looking that direction, because you can just see the little strip of land here. That's 20 miles away. So as we get an extension of the horizon and we see further, so here, your perspective only goes to this point.
So
bottom left.
For each one of these, you went to the same spot and you
this
used
is
the
the
camera
same
at
spot.
exactly the same height. Just
Yep.
goes without saying, right? Okay.
Yep. This is all on that Grange Jetty. This is that rock wall that I pointed out before. So I'm on Grange Jetty right here.
Yeah, for the people who are wondering just what part of this is mirage, take a look at the top right frame, and you know that all of those sails are actually a complete triangle. They don't crop in at the bottom on the way down to the boat. And
Exactly. They're not a diamond.
Mirage.
Yeah.
Exactly.
Yeah. They're not a diamond. And as you can see here, so now we know that these aren't in the shipping lane. The shipping lane right there is 8 miles away. We know that they're not in the shipping lane, so they're closer than that. So they're probably really only about 5 to 6 miles away, because there's no way that they can be in the shipping lane, because that would be illegal. So we know that they're not 8 miles away. They're closer than that. And I would say that they're probably only about 5 or 6 miles away.
What were you saying earlier about the diamond shape? What was the significance of that, of the sails?
Oh, he was just pointing out that the sails aren't like that. Clearly the sails just go to a triangle. This diamond-shaped part underneath here is a mirage.
They don't all terminate in a flat bottom a meter before the end of the horizon, right? Like obviously that's refracted.
Okay, so then here we're looking at, this is looking at Brighton, and on different days, we see here, this is a 3 mile horizon, 3.5 mile horizon here. This is 9.5 miles away down here on the right-hand side. We can see all the way to the shore there on this day. We can bottom right, we see all the way to the shore, and we see the boats all the way. And on these days here, what I'll do is I'll escape out of here. And just as so if we look here, you can see that this is it's just in an inferior mirage just there. We can't see the shoreline down here. We can't see the shoreline at all down here. Right? This is in an inferior mirage all the way here. We see this boat here. We can't see the boat. It's gone. All the bottom of it's gone. But it's just perspective because now we have a closer horizon. This is disappearing at a faster rate. We go to this one and we'll see this boat come in. This is 3 miles or 3.5 miles. This is 5.5 miles. This is 8 miles. And now we see the whole thing all the way down to the shore. You can even see the seaweed and stuff down here. And then again, you can see all the way to the shore.
Oh, I know what's happening. The Earth curve is actually fluctuating at different distances based on being the same radius on those different days somehow.
Earth's
That's
breathing.
why-
Yeah, as Widget says, it's doing yoga. It's breathing in and out. Okay, so within our cone of perspective, we obviously have a sky cone where everything goes up and down, and then we have below our eye line, everything going up. So from here, as we see something come towards us, as it comes towards us from underneath our eyes, it will appear to drop. And if it's above our eyes, it will go up until we get to the right to us. And that's why I say that you are also the dividing line of perspective, because right where you are is where perspective changes. Everything from every direction does this. So this does this in a 360-degree circle around you, no matter which way you look. And you are the dividing line of that perspective.
That's pretty excellent. Wow, that's an excellent way to put it both at the same time.
Yeah. So yeah, that is how you see. And it's like every single thing that you can ever look at is how you see. So no matter what surface you look at. So if you've got 4 different flat surfaces at 4 different levels right now, the perspective is different on each one of those levels. So if you're looking at a table, everything is at a certain perspective. If you now would have a table that was closer to your eye line, maybe just like at your nose level, everything you see on that table is completely different. And if you then look on the floor, the perspective of everything you see on the floor is completely different again. So no matter where you look, the way that you see in perspective, everything will look slightly different. Now, for those who are actually on the plane, that's what they would be seeing.
Can you get back to the cone real quick?
Yep.
That's so awesome. And if you note the white there, right, it looks like the classical, like the Chinese farmer hat that makes the cone shape. So when I was looking into Chinese cosmology, they actually described like how they view the heavens, like, you know, they're like as a rice hat, and they were describing that. So when you put it's identical. It's exactly the same. So like the light distribution of how they perceived they would see everything would come down. They would make this shape exactly. Just fast. It's always been this. It's never been any like what you're like. You know, you're not proposing anything crazy, or you know, this is what it's always been.
Yeah, exactly. For some reason, we've just lost it. I don't know why, how, where. I think it's because we went into the globe.
It's been guised as a globe and then fed to us in school when we were kids with cartoons. That's what happened to it. It didn't go away. It got mutated.
Yeah, it's like what? It's like, oh, what happened? How did we lose this? Starts with Jesuits and ends with Jesuits, I think.
Yeah. Well, speaking of, if we were to take, I think I did make a slide up, but I didn't put it in here. If we were to take this and move it up here, and it becomes here like this, we now have a square and compass.
Oh yeah.
Yep.
Right. So it's how we see as well. So the square and compass represents not just geometry, but the geometry of how we see. Everything up.
Oh, dude, they did the same thing. Classic. It's identical. Oh man, that's awesome.
So basically, everything that we see, we're just seeing in triangles and pyramids, basically. Either an upside down triangle or a
always has been.
Yeah. So everything is basically just a triangle or a pyramid in the way that our vision works. And so, yeah, the people that would have been in that plane, that would be them. They're just seeing water all the way around them. The horizon line, it's up here. This white circle here would be their horizon line, all the way up here, rather than, you know, it's not down here for them. They're not seeing the horizon down here. They're seeing the horizon up here. Okay. So here is where I started going into it, and what started really kicking me into the idea of like, this is basically just perspective on the opposite side. Because what's going on for these people here? Anyone looking from this jetty back towards me is seeing this same thing here. That's what they're seeing. They're seeing water go up like this. That person way down there is seeing exactly what I am, but just from the opposite side. And then now if they're looking on this day and they're looking back towards me, they're going to be looking all the way to the base of my jetty. So we don't have the same perspective anymore. It's completely changed. Your perspective only goes to here, because this is the furthest visual point you can see. This is the dividing line of your perspective. This is where your perspective divides. This is like a basic wall here. And from there, now it drops off. Now, this is a very common, this is basically what I see. Now, I've got way more days, but like there's so many days that I've done. From these pictures, I've got 100 days that I've actually put into a keynote. And out of those 100 days, 32 of them are like this. 50 of them have an inferior mirage, and then the others are anywhere in between that. So when you have an inferior mirage, you get hidden. And the ones that are in between that are in between this and the inferior mirage. So what you'll actually see is as an inferior mirage is building, you'll see all of this start to come towards you and appear like, and everything start to drop below, because now your perspective has to change, because as soon as the horizon starts moving towards you, everything from beyond the horizon starts to drop. But this is what actually did it for me. And this one screws them over every time. I'll show this and I'll be like, oh yeah, there's a jetty below there. What's going on? Oh, well, clearly that's the Earth curve. And I go, oh, well, what about now? Where'd the Earth curve go? Because the moment anyone who believes in the ball sees a horizon, that horizon must be Earth curve. They don't have another answer. The horizon is Earth curve. So if you don't see anything below this horizon, it's because it's gone over the curve of the Earth. But clearly, this hasn't gone over the curve of the Earth. There's actually, you can just see water beyond there. So there's the 8 mile mark, and up here is where the water is, just there. And here, that water there, the jetty is about there. So I think I did have lines on here before, probably. No, I'm not going to do it. It's going to waste time. But the horizon line, or like this line right here, is about there. So there's water beyond that. That's 1.5 miles of water in between there and there. And so this one really messes them around because they don't really have an argument for it. All they can say is that this is where the Earth curves. But it's not where the Earth curves. It's just refraction. And that's why I say that the horizon is caused by your personal eyes, your height above the surface, and refraction will tell you what the distance to that horizon will be at any given moment. And that refraction changes constantly. So I've had it before where it looked like this, and 2 hours later, it looked like this. So it's in constant flux. It's always changing. Okay, so this is where I represent, basically this is what's going on. So you have your perspective going up here, and then their perspective going back down. That's what they're actually seeing. They're seeing the same thing, just reverse it. So they're seeing perspective like this. That's how they're seeing the world right now if they're looking back towards me. And on this day, it's going all the way out. So if we just skip between these two, see our perspective has to change because now we're not seeing only 3 miles away. Now we're seeing 8, 9, 10 miles away. And everything will change. See the way the buoy here? Look at the buoy. Let me go back here. So see how the buoy raises and drops, raises and drops, raises and drops. It's not rising and dropping. It's literally that refraction has put the horizon right here, and the horizon is the furthest point that you can see the surface. You can't see beyond the horizon. So now when the horizon moves further away, everything needs to correct itself. The entire scenery corrects itself because now perspective is going all the way out here. Whereas before it was here, now it's here.
Are you suggesting there's some kind of dynamic rendering that's applicable to changes in perspective?
That is one way of putting it.
Although that the temperature gradient changes with the density and atmospheric conditions so much so that it can appear to put the horizon at a different distance based on the conditions of the day.
Exactly. So what I would say and what I put forward is that the horizon is the point where the light is beginning to bend, and it's beginning to bend upwards. I think it's always bending upwards. It's just some days like this, it's traveling much further before it starts to bend. So we're seeing further.
The effect is obvious, but frame to frame here, I'd like to see the anchor point be set on the buildings at the top center of the image.
Yeah, I mean, it just,
you know what I mean?
But
between these two, you're saying that the horizon line is dropping to the July image here, but so are the houses above. If they were matched up static one to the other, then, I mean, we would see the same thing we're seeing here, just a little less pronounced, I think.
Yep. So, oh no, hold on, I can't do that.
No, it's literally about recropping the second image, the July image, so that the house up top is a little bit higher, like it is in the September image. That kind of thing, yeah. There, see, that's kicking ass.
Wow.
Yeah.
That's kicking ass. Now you're talking.
Oh, yeah,
that's telling you what's going on.
It's going a little bit high. Let's line these two. Let's line these two houses
That's
up.
much better.
Yep.
Nice, Stone.
Yeah, it just all depends on where you want to place it. I was just lining this up, but yeah.
Precisely. But what I'm looking to do is take away the Globey objection. That's obviously deletable. You know what I mean?
Stone's always looking to take away the Globey objection.
Give them as little ammo as possible because otherwise they start flinging shit or whatever, you know?
Yeah, and real quick, before you move on to the next slide, can you go back to the one that shows the two side by side that are 2 hours apart? There we go. Thank you.
Oh no, these ones are 2 hours apart. But I've had the similar thing 2 hours apart. These are different days.
Oh, gotcha. Okay. Well, like I wanted to see those again real quick, so just put those up, and then you can move on now.
Yeah. So, and you know, I can show you probably 400 of these from different days.
Yeah, I mean, there's the classic Skunk Bay one. What is it, like a snapshot from every hour of the day, and it's just the horizons all over the place.
Yep.
Up and down. So,
yep.
Yeah, carry on, sir.
Yep. So here's another one where we see the horizon higher. So now we can tell more that this is an inferior mirage that's building, right? So we see a nice high horizon there, the buoy all the way up there. And here's that same day, the 19th, and we see how everything seems to be really hidden here. Okay, this is just still on the same day, the 19th.
Oh yeah,
You see that?
Paul, we're coming up on our 2-hour mark. So
Oh, we are?
yeah, we got 12 minutes left, I think. So
Oh shit, there you go.
yeah, as you get closer to a point you want to close on, we could round off there and then pick it up next week or the fall or some other week to finish it off.
No worries. Let me see where. Okay, well, actually, right here is where the next section would start. So we'll just wrap it up after this little bit here.
Awesome.
And then we'll go into the next section like next time. But so
Neat.
here we can see these chimneys here. We can see a buoy there, right? And then we see that this is now disappearing here because it's now going just beyond that. We see this here. We see this. Yep, that's all good. And then when we go here, there's those chimneys. There's that house. Oh, there's that shed. And this line here is this line here. So this house here is this house here. Perspective, our entire perspective of everything has changed. Here we have this sailing boat here, which is well beyond this buoy now. Whereas when we're looking at it here, the buoy's all the way up here. In that same aspect of when we looked at, the difference between these two. So all it is that the moment a horizon is created, we create perspective. And when that horizon moves closer to us, perspective on the opposite side of that horizon also changes. So on this day here, anyone way down here would be able to see me on the jetty. But on this day here, you can't even see that house. So how are they going to see me? The entire perspective of everything that is going on here has to change. And we just see the entire world differently. But the horizon itself is what blocks everything. And the horizon is created by refraction, and the horizon is created by your eye height above the surface. And then we can just leave it at that.
Dude, that's
Yeah,
a
thanks for
whole
having me, guys.
bunch of visuals showing. I think because it's always been my position that like the observer's position above the horizon is why things disappear bottom up, right? I've always argued that. And my go-to example for the opposite was, well, if you go and change the conditions so that you can make things disappear top down. If you go in a hallway and you move the observer to right the middle of the hallway, then you can see it equal. You move it above the middle point, then you can see things disappear top down. So you can create the inverse conditions, and what you're doing here is the absolute, like it's the absolute same thing, right? You're just proposing that the horizon goes the opposite direction, and then you get the same reciprocal angular loss of information as it approaches and recedes.
Actually, let me just do this quickly, all right? So this will take just a moment because I did this. This is what I did yesterday. Now, my friend was the first time using the camera, so sorry that this is going to be a little bit blurry, but I'm standing on Brighton Jetty, and we got a mate of mine to go off with a boat, and we see him getting progressively higher. Right now, my friend couldn't see this boat at the moment because we've got a horizon here that's 3 miles away, quite a big inferior mirage. So my friend couldn't see this boat at the moment. It wasn't until he got to probably about here is where he could see it, but he still wasn't finding it just yet. It wasn't. You'll see where I go into a split screen is when my friend finally found it because he was having trouble trying to find the boat. But right here is where he found it. So he's looking at the boat here, and I'm looking at the boat here. This is the same point.
Right, so you have two observers at opposing points viewing the
Yep.
same thing, approaching and receding, and that's what you built your diagram on for the rest of the thing was this exact example.
This exact example, like, is everything rising and then falling, right? So this is absolute, like, solid evidence and solid proof of everything that I've just been saying, right? So from here, now this one here has gone up and is now starting to go out of my vision, and it's come up through here and is now starting to come into his vision. And what's going to happen is as it goes here, for me, it's going to start disappearing. And for him, sorry, he was focused out, totally out of focus. So, but see now how he's dropping below the horizon? There's the horizon line cutting across there. And look where it is for me. Now it's disappearing for me. It's almost completely gone now. Right there. And then as it gets closer and closer to him, it drops below the horizon. It's gone for me. There's no point. I don't see anything. So it's dropping below the horizon for him as it gets closer. And it's like, you can see that it is all the way down here below the horizon. So it's a bit hard to skip through this. Go and get the right spot, you moron. Anyway, you get the idea. There we go. Right. So you can see how far below the horizon that is appearing now. As it got closer to him, he's probably like still a few hundred meters away. And then he went back, turned around and went back the opposite direction. And so now we see him climb up again. I still can't see him just yet. And then I got vision of him about here, right there. Right. So now I start to see him. He's climbed up out of the climbed up to the top of the horizon here. I'm just starting to see him as he gets to that horizon. And then from there, he now starts to drop as he comes towards me. So it's kind of like what I'm putting here, what I'm putting forward here. It's not just an idea. It's what happens. This is what happens within our world. This is how we see. The moment a horizon is created, everything beyond that horizon creates perspective on the opposite side. And that is exactly what we see when you see this. I have my perspective on my side, and he has his perspective on his side.
I mean, I remember your first presentation. You depicted this with like Harry and Sally and stick figures, and it was such a good thing. And now you have the real world example with the actual from each side showing exactly the same principle as you first illustrated.
Yeah, and that's why I've been sort of developed. This whole thing's probably taken me a few months to put together now. But yeah, like I've known this now, and I've had all this going. I should have had this done months and months ago. But obviously, life happens, lots of things going on. So it's been a sort of slower journey getting it all together. And the problem that I also have is trying to figure out how to present this in some kind of flowing way so that everyone sort of comes along for the ride. And so I don't know if I'm getting it right, but we'll get there. We'll get all the information there.
Yep,
so the next lot of
practice,
things, the next part of here is what we'll go into is me debunking Zanuck, and this is these ones. Well, let's go to a picture of it.
Nice. Going now. So in the next series, we're going to learn how to take all this information and take it into battle.
Yeah.
Nice.
Yeah. So we're going to go over this, and then that's where we have something like this, and we look at different examples.
Nice.
Of the same thing.
That's a great way to flow it out. Go over the basics, teach the root concepts, and then how to apply it in battle. That's awesome.
Yeah. And now let's think of this one thing for a second. You see these two images? They're the same thing. See how this one here is high because it's on the horizon, and this one here is low because it's in front of the horizon. And now imagine we're looking here. This one here is high because it's on the horizon, and this one here is low because it's in front of the horizon. So this is almost like as if you're one observer looking from one horizon, and now this is the observer looking from this direction. So this observer over here is looking this way, and this is what he's seeing. Does that make sense to you? Because this is perspective, right? So here, he's looking at perspective going this direction. So if there was an observer way over here, this one would look low, just like this one does, because it's in front of the horizon, and this one would look high. But we'll go over that more later. But yeah, these are basically the same observation, just as if you're looking from different sides of the horizon. It's like one's looking from the left, one's looking from the right.
Yeah, that's great. I haven't heard anyone put forth both sides of it like you did so adequately and thoroughly. So it's a really good contribution to be able to present it that way. That and the cone of elevation that you add to everyone's perspective bubble, if you will, which really gives it a visual depth, which is what's happening for sure.
Yep. But it's literally this part is that I want everyone to get the idea of, that things are disappearing identically on both sides of the horizon. So what we've been gaslit.
Right?
We've just been gaslit into thinking that we had to be looking beyond the horizon because everything was like, oh, well, what's happening beyond the horizon? So we've been looking beyond the horizon, trying to explain what's going on there. But the gaslighting was we should have been looking in front of the horizon because the same thing happens in front of the horizon. We just have an equal and opposite reaction from both sides.
Right on, man. Good digging.
Good stuff.
All right, thanks, man.
Yep. All right, lads, we'll go ahead and see. I was monitoring chat the whole time. There weren't really any questions. Everyone seemed to be getting it pretty good.
There was a lot of complimentary comments to play
Lots of
reality.
compliments.
I saw that. Yeah.
No, thank you very much, guys. Yeah, I wasn't watching, obviously, the chat.
Yeah, it's hard to watch it while presying, but yeah, no, you crushed it, man. Very, very coherent and lots of awesome visuals. Dude, you upped your visual game to an insane degree. I can't wait to see what you do with Unreal Engine in the future. It's gonna be awesome.
Yeah, that's gonna be great. My plan with Unreal Engine is just to build something that's like 100 square miles, and then maybe up to like 1,000 square miles, so you can literally just watch mountains appear and disappear.
Did you see the thing that Zach made like a year or so ago? He recreated the AE map in the engine that they use for Fortnite. Yeah, so you could do something very similar with that for sure.
Yeah, a friend of mine went to play that, but he couldn't load into it because there was no one else playing it at the time.
Oh,
I think it works where other people need to be in there or something.
I'm not sure. I've never Fortnited in my life, and inshallah, I never do.
It's an interesting game.
Yep.
It's great for the visuals, though.
Yeah. All right, we got a resub here from Run Boston Bear. Or no, yeah, it says legendary presentation. I sent this to FE Dave so he could use it in some of his interviews. Thank you for your hard work and seeking the truth.
Yeah, no worries, RBB.
The president bringing his support. He supports hard when he supports.
He's the man. He's the mayor. It's the mayor, isn't it?
Now we elevated
He,
him
he-
to
he-
president.
he-
Presidente.
once-
Yeah.
he started as the mayor, and then through political subterfuge and what can be only considered as bullying, we promoted him into president in a race that definitely wasn't fixed. Was very honest and open. We didn't rig anything at all.
You had no votes under the table.
Right.
There was nobody else to vote for.
Yeah.
Well, no, yeah, we don't say that, but that's how it was totally fair.
It was a race of one.
Yes. All right. Let's see here. Has a request. Oh, please can Paul meet me? I have hundreds of hours of from Deception Bay Boot Tramp on Mortron Island in Bribby. And I want to edit the old dog to learn. So this guy wants you to reach out and become friends. A great way to contact Paul is I linked his Twitter earlier. You can send him a DM on the Twitters.
Yeah, you can do that. If you're on Discord, you can always DM on Discord as well.
Oh yes, if you're on Discord or Telegram as well.
Yeah, Telegram too.
Most people won't do that.
But yeah, Twitter if you got that.
Cool.
Yeah, if he just wants to go over his observations and then we'll sort them all out. Like literally every single observation in the world fits in this because that's just how we see.
Oh, he
There's no
said he said boat ramp, but I read it as boot tramp. So sorry.
Yeah, I was gonna correct you, and I was like,
Boot tramp.
it's fine.
Yeah,
It's fine.
yeah, it's fine.
nothing
Sometimes
like a good
I
boot tramp.
miss a word there or letter. But yeah, awesome Prezi dude. We will be back next Sunday. We'll either be following this series or starting a new and then picking this up on another week or something. We'll see what the scheduling's like for you. But yeah, awesome dude. And then coming up Monday night, we have Celestial Theodolite update number 22. That'll be on Earth Awakenings, streamed on my channel. So check that out if you're following the escapades of the Celestial Theody. We're going to be going over a simulation that Goose made to kind of illustrate the math that Mike's been putting forward. So when we look at the math, we see a lot of notations and like, what does all that stuff even mean? Well, hopefully the sliding scale simulator will help illustrate the significance of what's being put forward there. So we're going to be going over that on Monday. And then Tuesday, Shane's going to be breaking into the history of the dam era, where over the course of about 50 years in the United States, every dam like known to man essentially was constructed. And then shortly thereafter, there was a little drought, a little spout where there was a drought or lack of spout. I don't know. There was a drought for the old Dust Bowl. So he's going to be covering the history of the construction of all the dams and how that all went down. So that'll be awesome. And then Friday, of course, will be the Twitter community space. So tap in with the lads over on Twitter.
Nice. Thanks everyone. Thanks Plain Reality.
Yeah, no worries. Thanks for having me.
And Stone, did you have anything going on or any updates you want to deliver? I think you've been talking to us.
We're out of time, so I think we'll keep the updates maybe till next time. It's not pretty, and would take far too long to talk about right now since we just hit the second
All right,
hour.
I'll sum it up though. So there's a lot of grandstanding going on. There's been no progress, and as long as there's no resolution due to the grandstanding.
Hi, everybody. Nice to see everyone. Hi, girls. How are you? Sorry, I left so